Yes, class. So yesterday, many of you couldn't write the question as well. So write down the question, then I'll start the discussion. See, class, the total resistance which we have to calculate, it is in series combination. So simply for R equivalent, we'll be adding R1 plus R2. So this is 5 plus 10, which is equal to 15 ohms, right? So straight away we'll add them for the total resistance. Now you should be aware whenever you are calculating, whenever you're performing this calculation, you should be aware of the fact whether this is in series combination or is in parallel combination. For sure, if it is in series combination, please add it directly. Why am I saying it? Because it becomes confusing when we compare it with the capacitors. In capacitors, we do not add the quantities which are in a series. We reciprocally add them. So just have it in mind that you have to make it opposite. Second part says total voltage. Now this is a series combination, but total voltage is this. Total voltage means the total circuit voltage. That is whatever is the value of this. So this becomes 10 volt value of the total circuit which is connected at the end. Third says total current. Now this is series combination. Total current is the total voltage divided by the total resistance. So what is the total voltage? See, current is equal to V divided by R. Total voltage is 10. Total value of current is, total value of resistance is 15. So this becomes 2 by 3 amperes. Total current done. Voltage across each. So individual voltages we have to calculate. See, V1, IR. Current is the same. So R1. So what is the current? 2 by 3. First resistance is 5. So this becomes 10 by 3 volt. And when we are calculating V2, which is I into R2, it is 2 by 3 into 10. So this becomes 20 by 3 volt. See, 10 by 3 plus 20 by 3 is 30 by 3, which is equal to 10 volt. So it means we have divided the current properly. Last is current across. This is a series combination. In series combination, you get all the values same. So in the fifth part, I1 is equal to I2, which is equal to I, which is equal to 2 by 3 amperes. Fine. Write down the solution, then we'll come to the parallel combination. Write it. Okay, class. Now come to the parallel combination. So in parallel combination, we have already discussed that voltage will remain the same and current will be changed. So total current here we'll add, that is I1 plus I2 plus I3 till IN. Now when we use the Ohm's law, V is equal to IR from here. If we write the value of I, which is equal to V by R. So V by R equivalent is V by R1, V by R2 till V by Rn. So from here, voltages will be cancelled. So finally, we have 1 by R equivalent as 1 by R1 plus 1 by R2 till 1 by Rn. All right. So this is the formula of it. And see, now we'll have different values of current. So V by R1, V by R2 till V by Rn. Similarly, power will be V square by R1, V square by R2, like V square by Rn. Now this question, at least all of you have to solve. Otherwise, I'll be calling the names because in series combination, nobody had answered. So first write down this, I'll show you the question, but at least this question, it's a very easy one. These types of questions I'm going to discuss myself. But at least these kinds of questions, I expect the answer from you all. So please answer. First write it down, then let me know once done. I'll show you the question and answer one by one. One or two parts here and there, they can be understood. See, the first part, anyone is answering? Okay, last 2 minutes
Yes,
then.
ma'am.
Ma'am,
Fine, take 2 minutes. See, okay, what done, Yaya? What is meant by done? This was a question given to all of you, not to just write down the question that you're telling me that you've written it.
No, ma'am, I solved that.
So where are the answers? I could only see Rishita's answers. That's it. Nobody else has answered. Now Zaina is answering. Other students, Yaya, where is your answer? Sidra, Khadija. This was a very basic question. Okay, 3 students have participated. Rishita, Zaina and Yahya. Fine. See, R equivalent, 1 by R equivalent when we are calculating, it is 1 by 5 plus 1 by 10. So this becomes 10 plus 5 divided by 10 multiplied to 5, right? So R equivalent will be 50 divided by 15, which is equal to 10 by 3 ohms. Now, students who have answered the first part as 3 by 10, you have told me that is 1 by R equivalent. For R equivalent, you have to reverse it. So Rishita's answer is right. You have to reverse. See, those who are not answering and thinking that it's an easy question and you all will be able to manage it, these kinds of mistakes you commit. So other students who have at least attempted it, it's good. They'll be knowing their mistakes. So you have to reciprocate it, class, whether it's a question of capacitance or resistance. Do not forget to reciprocate it. All right. So 1 by R equivalent is given. You have to find out R. Total voltage be 10 volt. See, total voltage is the total voltage of the circuit that is given to us. It is 10 volt. Third part says total current. So the rule again remains the same. Total current is total voltage divided by total resistance. Total voltage is 10, total resistance is 10 by 3. 3 will go up. So 10, 10 cancels. This is equal to 3 amperes. Okay, second 2 voltage. Third one 100 by 3. Third one 3 amperes, Rishita, right? Not 100 by 3. Yeah, just check the calculation. I think somewhere there must be error. Or I
Yes,
think
ma'am.
you have just multiplied instead of
I
dividing.
send the new answer below
Uh,
that. 30 by 10 or 3.
Then fourth part says voltages across each. See, this is a parallel combination. So when you are calculating the voltage across V1, V2, all are the same, which is equal to 10 volt. And last part says current through each. Individual current we have to calculate. Look here. For individual current, first current is equal to, see, voltage is the same, but R1. So it is 10 divided by the first value of voltage, it is 5. So this is 2 amperes. Second value of current, this is V by R2, which is equal to 10 divided by 10, which is equal to 1 ampere. Now class, for checking, you can add it also 1 plus 2 amperes. This is equal to 3 amperes, which we have got initially already. So yes, yeah, right. 2 amperes and 2, 1, Rishita, correct. Zaina, you have not calculated the third part, fifth part. Okay. Okay, all of you, write it. All those who have calculated or not, write down the solution. See, we'll start with this part. Let's name all these. This is 1, this is 2, this is 3, this is 4, this is 5th and 6th. So R1 and R2, they are connected in parallel. Right now, one thing class, when these two are connected in parallel and they are identical, so simply divided by the number of resistors. Like 3 resistors equal, so R by 3. 2 resistors equal, so R by 2. So not R equivalent, this will be, it's not R equivalent, it will be R12. This will be equal to R by 2. Fine. So we can replace this entire by a single wire and put it as R by 2. Like this. Now see, R12 with R3, they are connected in series. So R12 and R3, they are connected in series. So R123 is equal to R by 2 plus R. So this is equal to 2R plus 2R, which is equal to 3R by 2. All right. Now we can replace this with a single wire, which is 3R by 2. Now look, this R123 and R4. R123 and R4, they are connected in parallel, right? So it means 1 by R1234 is equal to 2 by 3R plus 1 by R. So we'll have to multiply 3 here. 3 plus 2, 5 by 3R. So R1234 is equal to 3R by 5. Now we can replace this entire by a single wire, single resistor, which is 3R by 5. Now 3R by 5, all these three. So R1234 and R5 and R6, all these are connected in series. So finally, R equivalent is 3R by 5 plus R plus R. So this is equal to 5 and this is 3, or let's write it as 3R plus 2R. So this can be written as 5. This is 13. So 13R. This is the final answer. So such questions you have to solve step by step. Start writing it from here. completed?
Yes, ma'am.
Okay, class. Now, when we have infinite series, so in infinite series, there are how to solve this is that you have to identify a repeating term. So 1 ohm is connected to 2 ohm, ohm is connected to 2 ohm. So like this, if you see, this is the repeating term. So what we'll do, we'll assume that entire infinite series answer is equal to R. Assume that R equivalent is equal to R. Now what we'll do, if the entire resultant is R, if we add one series to this infinite series, that won't make any difference. That will still have our answer as R only, right? If in this infinite series, if I just add one more repeating term like this to this final R, I still have my R equivalent not getting disturbed, right? And at least I can solve this to get my final answer. That's what we have to do in infinite series. I'm repeating. Identify a repeating term. Or just assume that this entire answer to this question, this is R. So if the entire answer to this entire infinite series is R, if I just add this term, repeating term, if I just add a repeating term, 1 ohm and 2, that will be equal to, that will still be equal to R only, right? So we'll add one more repeating term and R equivalent should remain the same. It means here in this particular question, R and 2, they are connected in parallel. So if R, so 1 by R1, this is equal to 1 by R plus 1 by 2. This is equal to 2 plus R divided by 2R. So R prime is equal to 2R by 2 plus R. That still didn't solve the answer. That is just R prime. 1 ohm is still there. So they are connected in series. If they are connected in series, so the final answer, R equivalent that I'll have, it will be 1 plus 2R by 2 plus R. Now, what is R equivalent? R equivalent, we have already assumed that this R equivalent, this is actually equal to R itself, right? This is equal to R itself. 1 ohm. Let us solve this first. So 1 plus 2 plus R plus 2R by 2 plus R. So this is equal to 3R plus 3. 1. Oh no, this 1 is not there. I have multiplied. It's just 2. So it is equal to 3R plus 2 divided by 2 plus R. Now class, this entire term which I have got R equivalent, this 3R plus 2 divided by 2 plus R is actually equal to the R equivalent, which is R. Because just by adding one repeating term, that doesn't change our answer, right? So if we multiply this, this becomes 3R plus 2 is equal to 2 plus R squared. So R square minus R minus 2 is equal to 3. So R square minus 2R plus R minus 2 is equal to 0. So here R, this is R minus 2 plus 1, this is R minus 2 equal to 0. So we have two values over here. This is R plus 1 and one is R minus 2. So from here, R is equal to minus 1 ohm, which is incorrect and invalid. R is equal to 2. So this is our final R equivalent. And what was the R equivalent? R equivalent was the value which we had assumed in the starting itself. And R equivalent was the term which was valid for the equivalent resistance series. This is how you have to solve infinite series. It's a separate case that comes. It's a unique case that comes. So this way you have to solve. Just text me anything if you have any query in between. Start writing from here and mark this as, make a note and mark this as infinite series separate. Class, this is a question from Wheatstone Bridge. So how do we analyze this? That this I have told you when we were discussing uh, capacitance. That time I had told you that how do you see the conditions? You divide. See, 10 divided by 20 is equal to half. 20 divided by 40 is equal to half. It means it's the bridge is balanced. So it's the balancing condition. So if it's the balancing condition, it means we can remove this. Okay, it means that we can remove this. So this would be the case. So these are connected in series and these are connected in series. Means this becomes 10 plus 20 is equal to 30. And this becomes 20 plus 40 is equal to 60. Now I have these two 60 and 30 left for the parallel combination. So our equivalent, this will be equal to 30 into 60 divided by 30 plus 60. That would be the final answer. Correct, class? So this will be 1800 by 90, which is equal to 20 ohms. This completes with the circuit practicing. Lots of circuits. We have practiced different types of circuits. Write it.